Okay, algebra. This is radical expressions, so things underneath of square roots that we're going to be simplifying in this video. This is kind of a section that's, people struggle with a lot, so we're going to go through kind of this background part and hopefully clear up some things on simplifying these guys. So first they have us list out up through 144, the perfect squares. So 1, 4, 9, 16, 25. That's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. 6 squared would be 36. 7 squared is 49. 8 squared is 64. 9 is 81. 10 is 100. 11 is 121. And then 144 is 12 squared. So we could add to that 13 squared is 169. 14 squared is 196. 15 squared is 225, and we can keep going from there. I usually add in 13 and 14 just because 169 and 196, those are easy to remember. They're just flipped around, okay? So these are perfect squares. So if I would take the square root of any of those numbers, they would come out as a nice number. In addition to that, if we have variables, a lot of people think that like x to the 9th power, if you take the square root of that, that's x to the 3rd power, right? Because the square root of 9 is 3, but it does not work this way for exponents, okay? So cross that out, do not put that there. When you're taking the square root of exponents, they need to be even numbers, okay? So nice square roots would be x squared, or x to the 4th power, or x to the 6th power, or x to the 8th power, or x to the 10th power, okay? They have to be even powers. So like the square root of x squared is x, the square root of x to the 4th is x squared, this would be x to the 3rd, this would be x to the 4th, x to the 5th, and so on and so forth. Okay, so when you're taking the square root, it's like you're dividing the exponent by 2. Okay, so here we'll just do a couple of these. The square root of 25 is 5. It says because 5 squared is 25. Okay, the square root of 36 is 6 because 6 squared is 36. The square root of 100 is 10. The square root of 49 is 7. These down here, the square root of a to the 6th power is a to the 3rd power, because if I take a to the 3rd power and square it, it's 6. Okay. The square root of m to the 6th power is m to the 8th, because m to the 8th, if I square that, that is m to the 16th. Okay. A lot of people look at this m to the 16th power and say that's m to the 4th power because you're taking the square root of 16, but you're not. Okay. The square root of y to the 10th is going to be y to the 5th. You're dividing those by 2. Okay. The square root of a squared is just going to be a to the 1st power, or just a. Okay. So hint: divide the exponent by, I already said, 2. You're dividing the exponent by 2. Okay. So let's go down and do some of these down here. These first 4 problems are going to be pretty easy. The square root of 16 is 4. He comes out really nice. If we were solving this problem, like where we had x squared equals 16, if it was presented to us this way, we would end up inserting the square root. So we would take the square root of x squared and the square root of 16. And in that case, our answer is plus and minus 4, okay, positive and negative 4, because we inserted the square root. But when they start with just the square root of 16, that answer is just 4. So we don't have a positive and negative, okay. Number 3, they already have the negative there. So we just take the square root of 100, which is 10, and we slap the negative on the front of it. So it's just going to be negative 10, okay. And then number 8, there's kind of a string of things that we're doing here. So let's look at the negatives just hanging out on the front, so we just include him. The square root of 81 is 9, and then the square root of m to the 64th. Okay, it's not m to the 8th power. Be careful of that. You're not taking the square root of 64. You are dividing by 2. Dividing by 2. So m to the 64th power divided by 2 is going to be m to the 32nd power. That's what that one will be. Okay. And then number 10, last one like this, the square root of 121 up here, that's in my list of perfect squares, 121, the square root of that is 11. So I'm going to bring the 11 out, okay. The square root of x to the 14th power, we're just dividing by 2, so that's x to the 7th power. And the square root of y to the 6th power is y to the 3rd power. So that's what he will look like, okay. Those are ones that come out nicely, so they are perfect squares. They say simplifying perfect squares. Okay, now we're going to go down and we're going to do ones that aren't perfect squares. So when you have the square root of stuff like the square root of 27 or the square root of 48, okay, what we do is, since 27 isn't a perfect square, I break them down like this, okay? And I want to find a number that goes into this spot in that circle that will go into 27 that I can take the perfect square root of. So a number that goes into 27 that I can take the perfect square root of is 9. And 9 times 3 will give me 27. So I kind of write it like that, okay? And then I write these as the square root of 9 times the square root of 3 gives me the square root of 27, okay? But then the square root of 9 is just 3, and the square root of 3 doesn't simplify, so that's 3 square roots of 3 is what that guy will look like, okay? All right. In the same way, for number 15, I know that I can't take the perfect square root of x to the 9th power, because when you take the square root of powers, you're dividing by 2, okay? And 9 does not evenly divide by 2, right? 9 does not divide by 2. So what I'm going to do is I'm going to break him down, and I'm going to find a value or an exponent of x that will go into 9, okay? Now, people pick low numbers. Pick the highest number possible, okay? When you are dividing, or when you're breaking this down, you will only ever have one x off to the side over here, okay? The rest of this will be x to the 8th power. So 8 plus 1 will give me 9, and I've broken it down. So you only ever hang one x off to the side over here. The rest of them are going to be inside of here, because this will then be an even exponent, and you can take the square root of x to the 8th power. Okay, the square root of x to the 8th power, if I divide by 2, is just going to be x to the 4th power. That's how he will pop out. And then I cannot take the square root of x to the 1st power, so I'm just going to leave him as the square root of x, and that's how he will break down. Okay, so you only ever hang one of them off, because then this will be an even number. Okay, if it's an even number to start with, like if this was the square root of, let's say, x to the 10th power, okay, I don't have to hang anything off because he's a perfect square. He would just pop out as x to the 5th power total. And I wouldn't have to do this whole tree diagram thing, okay? So he's just x to the 5th power and he's done. But when I have an odd power, I'm going to hang one of them off to the side, okay? All right, so let's go down and do number 24. This is one that I want to do, okay? So this one is one where he does not come out nicely. So I like to break him out into 3 pieces here. I'm going to do the 75. I'm going to do the x to the 7th power, and I'm going to do the y to the 5th power. And that's what I'm going to break him off into 3 pieces. Okay, and then I'm going to do each piece individually and then put them back together. So let's start with 75. Number that goes into 75 that I can take the perfect square root of, okay? Now, if you can't think of them, you just start going through this list, okay? And you want to pick the highest number possible. So 75, the number 75 is here, right, in between 64 and 81, okay? So I start with the highest number possible, and I say, okay, the 64 go into 75. 75 divided by 64. Nope. 75 divided by 49. Nope, not evenly divisible. 75 divided by 36. Nope. 75 divided by 25. Ah, there we go. Okay, so I want to kind of work backwards from the highest number, and my highest number we came out with was 25 and 3. Okay, now you probably maybe could do that in your head, but if you can't, do that process where you're finding the largest number. Okay, so the square root of 25 times the square root of 3 will give me the square root of 75. The square root of 25 is 5, and the square root of 3 doesn't come out nicely, so I leave him as the square root of 3. 5 square root of 3. Okay, now x to the 7th power cannot break down, or does not come out nicely as a perfect square, so I'm going to hang one of them off to the side over here, and inside here there will be 6 of them. The 6 plus 1 will give me 7. Okay, now if I do that, I take the square root of x to the 6th power, which is x to the 3rd. I take the square root of x, which doesn't come out nicely, so I just leave him on the inside, and that's how he will break down. Okay, same thing with y to the 5th. I'm going to hang one y off to the side over here. That means there's going to be 4 underneath of here. Okay, so then the square root of each one of those will give me y to the 5th. The square root of y to the 4th is y squared. The square root of y is just the square root of y. Okay, and now that I have everything broken down, I'm going to lump it all back together. So stuff that's on the outside, those three pieces, I just write those 5x to the third, y to the second. Okay, square root. I have a 3 and an x and a y on the inside, so 3xy, and that is in lowest terms. It's in the smallest exponent possible. Okay? All right, let's go to the back side. I have 3 of them on here that I want to do. So the first one is number 1. And the thing that I want to get across on number 1 is that when you have square roots, you can only add and subtract them if they have the same base, kind of like x squareds and x cubes. Like if I have 5x squared minus 3x cubed, I cannot put those two together because this one's a square and this one's a cube. Okay, I can't do those. In the same way, I can't put square roots of 5s with square roots of 6s. So what I can do is that this is a square root of 6 and this is a square root of 6. So I have 5 square roots of 6 minus 3 square roots of 6. I can put those together. Okay, 5 square roots of 6 minus 3 square roots of 6 is kind of like saying 5x minus 3x. So that will be 2x, or 2 square roots of 6. And then on the front of that, I'll just leave 6 square roots of 5. What, honey?
No. I want some more milk.
All right, I'll get you some more milk. Okay.
Is it good?
All right, hold on just a minute. Okay. So this is completely simplified. I can't do any more than that. Okay. Now, what I can do though, for like number 4, I told you up here that I could not add or subtract if they don't have the same base. But what I can do is, let's say instead this said multiply. I can multiply those together. Okay, 5x squared times 3x to the third would just be 15x to the 5th power, right? I would add the exponents for x and multiply the numbers in front. So same thing goes for when I have square roots, okay? So think of this as like 1 square root of 10. That's on the number on the outside. So I multiply the outside numbers together and I multiply the inside numbers together. So I have 3 times 1, which will just give me 3. And then I have the square root of 2 times the square root of 10, which will give me the square root of 20. Okay, now, I'm not completely done yet because the square root of 20 will break down. So what's a number that goes into 20 that I can take the perfect square root of? And that is 4 and 5. Okay, so if I take the square root of 4 times the square root of 5, that will give me the square root of 20, right? The square root of 4 is 2. The square root of 5 stays as the square root of 5, okay? Now, the problem with writing it this way is I had that 3 out there to start with, right? Okay, so this doesn't make 32 square roots of 5. It's 3 times 2 square roots of 5, right? And in that case, these two are both on the outside. I don't take the 3 times the 5 because he's trapped on the inside. So this will just be 6 square roots of 5. That's what he will look like. Okay, so when I'm multiplying, I can take two things that are different bases and multiply them together. All right, last one is number 9. I want us to divide. Okay, so when they have two radicals, one on the top and one on the bottom, what I can do is I can put them all underneath of one roof, like this. And I can simplify him, and then I can, like just break down and do whatever, okay? So let's reduce him or simplify him to start with. So 18 and 9, I can reduce those. This will become 2 and 1. Then I have c to the 3rd power and c to the 1st power, okay, which will give me 2 c's left over on the top. So I'll have 2 here and I'll have none down there. Okay, so that was kind of confusing. Let's see what I have left over. I have the square root of 2c squared on the top, and on the bottom I just have 1, okay? And really I don't need that 1 down there on the bottom, so I can just leave it as the square root of 2c squared, okay? And so then, last thing that I'm going to do is I'm going to do this, the square root of 2 and the square root of c squared. Okay, so let's see what I can do with these pieces. So the square root of 2, I can't even break him down because he's like really a small number. So the square root of 2 is just going to stay as the square root of 2. I'm going to leave him. Okay, but the square root of c squared, is there something I can do with that? Well, he comes out perfectly because he's an even exponent, right? If he's divisible by 2, he will work. So the square root of c squared is just c, okay? So what I can do is usually I put this c on the outside on the front, so this will be c times the square root of 2, and that's what he will look like, okay? All right, so we can put them all under one roof, and we can reduce and then simplify from there. All right. One more thing before I quit this video, I kind of want to talk to you about these last little bits. We won't do each one of these, but always whenever you're taking a square root, kind of think about where that number lives, like the square root of 18. Okay, and it kind of goes back to the first thing that we did, like 1, 4, 9, 16, 25. Those are all perfect squares. 36, 49, 64, 81. If I list all of those out, okay. So this is 1 squared, 2 squared, 3 squared, 4 squared, etc. Right? Between what two whole numbers does each value lie? So 18 lives right here. Okay. So 18 is between 16 and 25. 16 is 4 squared. 25 is 5 squared. So if I would take the square root of 18, it would be a decimal number that's between 4 and 5. Right? The square root of 18 is a decimal number between 4 and 5. 4.24 is what he is. Okay. I'll do one more of these. So 40 lives right here between 36 and 49. 36 is 6 squared. 49 is 7 squared. So he is between 6 and 7. If I do the square root of 49, or excuse me, square root of 40, he comes out to be 6.3. And so he is a number between 6 and 7. Okay, so just kind of think about that when you're typing stuff in to your calculator, just to make sure you're even typing it in right or whatever. Or if your calculator has an error or something, think about reasonable numbers and where that number lives. Okay,